What is up, gang? Mr. B here, bringing you another sweet, wicked, awesome math video. It's been an absolute crazy 6 weeks, guys. So, at the end of the summer, I accepted a new job teaching. Well, basically, it's distance education, and it was really hard to leave my old school. It's only for a year, but it was still a really hard decision to leave my old school and my old students. I love that job so much. It's been great, and I absolutely love my new students. They're absolutely fantastic. My new colleagues are great. So that's kind of why I've been ghosting the channel a little bit the last little while, but I promise to get caught back up, and bring you guys some great math content. So this year I'm teaching a few different courses that actually one different course that I haven't taught for a couple years, but I did teach for like 10 years previous, so I know it well. So I thought I'd make a few more videos for that particular course because I haven't really made many in the last few years. So this video is on a topic that comes up a lot in calculus and in pre-calculus, which is called grouping. So I got kind of a new setup going on here, guys. I got a new Windows Surface tablet. So I'm just going to see how this thing works, and if it glitches out, I apologize. I kind of rolled the dice a little bit, not getting an iPad, but we'll see what happens. All right. So grouping. So grouping basically is a technique for solving cubics. All right. So probably somewhere along the line in one of your math classes, you've learned integral zero theorem or rational roots theorem. So basically, the rational roots theorem is like a supreme version of the integral zero theorem, which was what my students learn. So there's also another technique that we can use to solve some cubics, which is called grouping. And it's particularly useful for calculus, for limits and things like that. When you come up with a cubic, chances are it's going to be you're going to have the ability to group it. But if not, we can always fall back on integral zero theorem. It's just that takes much longer, and it often requires a calculator to be able to do. So let's show you an example of what a cubic that we can group is. So I got it written down here. So 4x cubed minus 8x squared minus x plus 2. So when you get a cubic like this and you're asked to maybe factor it or solve for the x-intercepts, depending on what your objective is, probably the first thing that comes ahead is your rational root theorem, integral zero theorem, where you should take an extra second and just look at basically your first two terms, so the x, so this guy and then this guy, and then also look at the last two terms, so this guy and this guy, and think about what would happen if you took the greatest common factor out of each set of those. All right, so I'll rewrite it, and you'll quickly see why they call this grouping. So we call it grouping because we group up the first two terms, then we group up the second two terms. And the key, in my opinion, to not making a simple mistake is to always have a plus in between those two brackets. Because if you have a plus in between those two brackets, you're not going to mess up the signs. If you try and get lazy, and I've seen students do this and they group it like that, then you're just basically setting yourself up for failure. For all it is one extra step of rewriting the brackets. So now if you look at each individual set of brackets, we look at and sort of try to, before we even attempt to write it down, we try to see what we think would happen. So if you look at this one, I can easily take a 4 out and I can take an x squared out. So if I take a 4x squared out, then I get left with, on the inside here, just x, and then this one, 8 divided by 4, and then x squared divided by 2. And then this one, I can't really do much with besides take a negative out. So if I go ahead and take a negative out, black, I'll take a negative out, and I'll just write it there as a negative. And then it's, so I take a negative out, the signs just switch, just like that. So what you notice here is that I get the exact same thing in both brackets. So if that happens, it means I can group. All right, so it means I can group. So the key is you group up the first two terms, plus group up the last two terms, and then factor each individual bracket with the greatest common factor. Now, the next step is we want to write this in a little bit more of a friendly form. So the key is having both of your brackets be the exact same. So essentially what we're doing now is we're actually factoring out the x minus 2, which is in both terms. So if I factor out the x minus 2, that's now on the outside. And then what we have left is what's on the outside of the bracket. So 4x squared minus 1. Now, for the majority of my students, they don't really think about that, and neither do I. Like, I've done this so many times. I know why you can do this, but that's the why, the GCF, right? But if you just simply look at, okay, what's in front of the brackets goes in one individual bracket. So the x squared and the minus 1 goes in one bracket by itself. And then one of those identical brackets gets taken to the next step. So I just picked the x minus 2. One, doesn't matter which one, right? But essentially the reason why you're doing that is because you're factoring out the x minus 2 on the outside. Now, oftentimes you might have something that simplifies a little bit more beyond. So if you look at this, this is difference of squares. We got a perfect square, subtract another perfect square, so it ends up being 2x minus 1, and then 2x plus 1, just like that. So that's the factored form. If you're asked to take it another step further, then all you need to do is take each individual bracket and solve it equal to 0. So if you're asked to find the x-intercepts, take each individual bracket, set it equal to 0, and solve. So this one becomes x equals 2, and then we have 2x minus 1 equals 0. So we can add 1 to both sides. Get 2x equals 1. Then we divide by 2, and I get x equals 1 over 2. And then the last one is just the opposite of that one, so plus 1. So minus 1, 2x equals negative 1, divide by 2, x equals negative 1 over 2. So there's the 3 potential x-intercepts. And again, depending on what your goal is with this, factoring might satisfy it, but it could be something else that you need to do with it. Maybe it's graph it. So if you want to graph it, you got to have the x-intercepts. All right, let's try another example. I got this bad boy written down too. I need to get a better setup. I'm holding this tablet up here. It's kind of uncomfortable. So let's see. 4x cubed plus 2x squared minus 6x minus 3. So when you look at this one, and again, you have to be able to make that judgment call of whether or not you're going to group it or you're just going to jump to one of your other theorems right away. So what I would suggest is just get used to saying, like, okay, what happens if I factor out something out of the first two? So I can factor a 2 and an x squared. What do I get back from that? Okay, I can factor out a negative 3 out of the second one. What would I get back from that, right? So take an extra minute and just not even a minute, 20 seconds, and just kind of guess what you would get if you factored it. So remember, plus in between, and then that traps that negative inside the brackets. So then we can take out out of this one, we can take out a 2, and we can also take out an x squared. You're always going to be able to take out an x squared out of that first bracket. And then you end up with 2x from that first one. So 4x cubed divided by 2x squared is 2x. And then 2x squared divided by 2x is just 1. And then out of here, I'll take out a negative 3. And I get 2x plus 1. And again, you did it correct if you got the same bracket after each thing you factored out. So this is what my students do when they're doing this. They don't really think about, okay, I got to take 2x plus 1 out of both terms. All they do is they think, well, I got 2x squared minus 3. That's what's in front of the brackets. And then I'll just take one of the remaining brackets, 2x plus 1. And that's it. It's done. All right. So it's a great way of factoring cubics and saving yourself the time of having to write out all those possible factors and then checking them and all that kind of stuff. All right. So thank you very much for watching, guys. And again, I love the support of the channel. So if you want to drop a like or make a comment or share, I would really appreciate it. Every little bit of support helps me get closer to my goal of 100K ultimately, but I'd like to have by the end of the school year, maybe 25K. That might be a little bit of a goal. So thanks so much for watching, and I will see you guys in class. Peace.
2,000 years later.
It's over.
Go home. Go.